following example is intended to illustrate the basic steps required to generate an initial model of a building using the program ETABS. We will examine a 3-story Category 2 medical office building. We will use 100 pounds per square foot reducible live load on the floors, 24 pounds per square foot superimposed dead load. For seismic design, we'll use S sub S equals 1.5, S sub 1 equals 0.6 with a site class D. For the frame, we will use intersecting moment frames at every level using HSS 16 by 16 by 5/8 concrete filled columns and 21 by 62 reduced beam section moment beams about each axis. For the floor, we'll use an 18-gauge 3-inch metal deck with a 3.25-inch lightweight concrete topping supported by composite floor beams. The skin of the building will be a curtain wall exterior cladding system supported by the exterior framing, for which we will assume 20 pounds per square foot times the height of each floor for superimposed dead loads. We will use 16-foot floor-to-floor at level 1 and 14-foot floor-to-floor at the typical floors. We are going to model up to the top of the deck at the roof level with the weight of the rooftop structures and equipment screens included in the 24 pounds per square foot superimposed dead load. We will also interconnect the column bases using 36-inch square reinforced concrete grade beams. In plan, the structure consists of 9 grid lines in the X direction and 4 in the Y direction, both spaced at 30 feet on center. For the intermediate beams, assume W18 by 35 at 10 foot on center to support the deck. Model each floor of the structure using the same deck type and member sizes, with rigid diaphragms assigned to each level. The weight of the concrete and steel elements is to be included in the load case dead. So let's begin this exercise by finding the maximum elastic displacement of the structure in the Y direction determined using the equivalent lateral force method. So let's see just how quickly we can get this model running and determine the drift.